Hello there. My name is Dr. Daryl Boyd, and I'm coming to you on behalf of the Transformational Education Adventure Center, which is located in McLean, Virginia. It is also known as the T Center, and I will be teaching a STEM lesson. Today's STEM lesson is about density. Density. That's spelled D-E-N-S-I-T-Y. Density. So the demonstration we're going to do, if you want to follow along, here's what you'll need. You'll need some water. I have mine in a measuring cup here. Water, and you'll need some cooking oil, only a little bit. And also you'll need some syrup, again, only a little bit. And when I say a little bit, maybe a quarter of a cup, all right? Why? Because you need a container. I'm using shot glasses. So again, the amount that I'll be using of each of those liquids is pretty small, okay? So you'll need a shot glass or some kind of small container. You can use a small cup that you might drink out of. All right. Density is a very, very, very important aspect of physics and of science, and something that we need to really understand. Density, in mathematical terms, density is the mass of an object divided by its volume. The mass of an object divided by its volume. We tend to think of weight and mass in general terms being the same thing, but they're not quite the same thing. Volume is something that we can discuss, but volume has to do with how much space an object takes up, all right? The volume of it. The mass is, in the simplest of terms, we might think of it as weight, but keep in mind that your weight will be different depending on gravity, all right? And mass is going to be the same no matter your gravity, all right? So today, we are going to look at fluid densities. We're going to ask ourselves some questions. Which fluid has the greatest density? All right, and we'll be able to make what we call a density tower based on the different densities of the three fluids that we'll be using. So let's get started. First thing I want to do, just so you can see things better, is I'm going to take my water here and I'm going to dye it green. That way it'll be easier for you to see once we get rolling. All right. So I have my trusty stir bar here, and we have now green water. All right. So I'm going to take just a little bit of this green water and I'm going to pour it into this glass. All right, that's good enough there. Okay. Now, I have a question for you, and I want you to think about this. I'm going to add syrup to the container. Now, where do you think the syrup is going to go, or what do you think the syrup is going to do? Will the syrup sit on top of the water? Will the syrup mix with the water? Or will the syrup go to the bottom of the water? All right, hopefully you've thought about that. Whatever you think, that is your hypothesis, and now we're going to test it. Keep in mind, a hypothesis in simplest terms is an idea that you can test. A hypothesis is an idea or a guess or a prediction that you can test. And so we're going to test it out. So maybe you thought that the syrup was going to stay on top. Let's find out. So I'm going to take some syrup here. I'm going to add some syrup, and look at that. So the syrup actually went to the bottom of the container underneath the water. All right, so you can see it pretty clearly there. This green layer is our water that we dyed green. This brown layer is the syrup. All right. Now, why did the syrup go to the bottom? The reason the syrup went to the bottom is because the syrup has a greater density than the water. All right, we have another liquid here. Remember, we have some cooking oil. Now, what do you think? What's your hypothesis? I'm going to take some of this cooking oil and add it to my container. There are several options. One, it's going to sit on top of the water. Two, it's going to mix with the water. Three, it's going to go underneath the water but sit on top of the syrup. Or here's another option. It's going to go and mix with the syrup. Or here's another option. It's going to go all the way to the bottom underneath the syrup. Or here's another option. Once we add the oil, it will mix with both the water and the syrup. Those are just some example hypotheses that you may have. What do you think is going to happen? Where will the oil go? Keep in mind what we learned a moment ago. The syrup went to the bottom of the container underneath the water because it has a greater density than the water. All right, moment of truth. We're going to now add some cooking oil to the container. All right, check it out. Once I added the cooking oil, instead of doing like the syrup, it did not go to the bottom and go underneath the water. It also didn't mix with the water. It actually just stayed on top. Do you know why it stayed on top? All right, if you said it's because it has a lesser density or it is less dense than the water, you are correct. The cooking oil has a lesser density than water. Water has a lesser density than syrup. Or I can say it the other way. The syrup has a greater density than water, and water has a greater density than the cooking oil. And so what we've made here is a very pretty density tower. All right, that is our lesson for today. I hope you enjoyed that. I hope you learned something about density and why it's important and why liquids can stay on top of one another when you put them in the same container. All right, thanks so much for joining us, and I'll see you later.